Okay, so hello, my name is George Kelly. I'm head of UI development here at KX. And today I'm going to be introducing you to KX dashboards, and we're going to be building a streaming example using Kdb+tick from scratch. Okay, so what is dashboards? Dashboards is a data visualization tool. It's designed to be easy to use, so it's got an interactive point and click, drag and drop user interface. It enables users to query, transform, and present both real-time and static data. It's fast, it's built on KDB, it supports features like an end-to-end binary protocol, along with throttling, conflation, and caching. And lastly, it's extensible. So it's developed using HTML5, but supports embedding from Python or R. And it also has a framework agnostic API that lets you develop components to use in dashboards. Okay, so this is the dashboards interface. So I'm going to jump to the browser. And so along the top, we have a document toolbar with a listing of dashboards, new, save, the ability to toggle between a design mode and preview mode. And along the left-hand side, we have a component listing where we can search for components, or we can drag them onto the canvas, arrange them, and resize them. Then if we want to populate a component with data, we can do this from the component properties on the right-hand side. We can click the property. Now here, we're going to start. So let's get some data. So I'm going to query DFX quote table. That's good. And just like that, we've populated our component with some data. Now, we'd probably like to interact with this data. So to do that, I'm going to use a dropdown. And in my dropdown, again, I'd like to populate it with some data. This time, probably a distinct list of symbols. Okay. And now we have a list of symbols that we can switch through. But what we want to do with this is we want to link this to a view state. So view states are like an observable collection of properties that define the state of the view. So I'm going to use this selected property to store my selected symbol. Okay. Now the next step is I'd like to link this to the data. So to do this, I'm going to parameterize my data source. So I simply introduce a parameter in my query. I'm going to then use that, select from DFX quote. Okay, and here I'm going to choose the view state. So I'm going to use this view state as the parameter in my query. Okay, and just like that, now when I change my dropdown, I can then change the query and update any components that are subscribed to that data source. Okay, so this can be applied to other dashboards as well. Here we have a simple table listing symbols. And when I switch my symbol, the corresponding data source for the charts change, and the charts update to reflect the change in the data source. So just like that, it's easy to browse data. We can also do this with the drill down dashboard. So here we can explore the breakdown. So we can group and aggregate in the data using KDB, and then we can use a single view state to store the breakdown path so that we can explore and navigate through our data. Again, in demo health, we can switch through population, obesity, diabetes, and so on, browsing by ailment, but we can introduce a second dimension to the data and browse by state. So this is just by adding another view state to our query. And so you can add as many dimensions to the data as you need to. In the fitness tracker, here we've imported some data from a Garmin watch, but we can use this repeater control to link together these items, and we can then play back through the time series data, and all of the visual components remain in sync on the screen. So we can pause at any point, we can jump to any point, and see the data synchronized by time. Okay, so we've seen components that we can drag onto the canvas and arrange. We can then populate these with data from data sources. And these data sources can be parameterized with view states and linked to properties from components. So by doing this, we link view states to components to data sources, and we can create interactive visualizations from very simple entities. Visualization components, layout, input, and application components. The visualization components are very versatile. So whether you're drawing bars, lines, bubbles, areas, box plots, or violins, you can use the same component in our canvas charts. And this means that you have a common set of controls and properties. So once you learn how to do one, you can learn how to configure any chart. The same is true of our radial charts. So whether you're doing a radar, pi, or polar. We also have more specialized charts. So we can do tree maps or grouped tree maps, heat maps and contour, financial chart with a wide range of technical indicators, 3D charts with bars, bubbles, lines, and areas, hardware accelerated charts when you want to display a large volume of data, a network graph with a physical based layout. And if you can't find anything, we still have declarative grammars, so you can define your own bespoke visual. In order to guide you on your choice of visual, we have a visual decision tree available in Demo Visualize. And this lets you provide the insight or let you choose the appropriate visual depending on what you want to show in the data. So whether it's a comparison, a distribution over time with many variables, or a composition or a relationship, you can follow this decision tree to choose the appropriate visual for the job. It also works as a sample, so you can see how to configure the appropriate visual, and it also demonstrates that we have a comprehensive range of visuals. So to access data, you can use the code editor with autocomplete and hinting and linting and so on, as we did in the first example. Or you can choose from a list of predefined functions. So here your KDB developers can define functions on a processor node, and when your dashboard developer comes to create their dashboards, they can browse these functions and search them. Or you can build a query using the query builder. Here you have a point and click interface to build a query graph, adding nodes at each step. The nodes have a fixed function, so you have data source nodes, function nodes, filter nodes, update nodes, join. And the parameters to configure each node are more or less self-explanatory. So here in the filter node, you can see you can specify which columns you want, how you want them named, or a list of conditions, or even a nested group of conditions. In the aggregate node, you can specify which node you'd like to group by, and how you'd like to summarize the other columns via aggregate functions. You might also notice in the implementation how these forms cleanly map into the functional SQL forms. So here we can take these parameters and we can pass them through as strongly typed parameters. This is not only a performant way to execute queries, but more importantly, it's a secure way. So rather than having to build a string and check that it's secure, we can have strongly typed parameters passed into fixed functions in order to be evaluated. So that's a nice benefit. So binary transfer is an important part of dashboard performance. In a typical data visualization system, the data is retrieved in one format and then converted again. You could have a system that would query an Oracle database using ODBC, convert it into a Java object, and then send it down to the client as a JSON string. So by using KDB's binary column-oriented IPC format, we can then eliminate the transformation of data and maintain a consistent, compact binary format throughout the stack. Taking this light touch approach to data, we can then simply route it through the network, and as a result we can use less server resources and provide higher throughput and lower latency, so we can send more data and tick more frequently. Recently, we've begun to maintain this column-oriented data structure on the browser, and so we don't even have to parse the message into a JavaScript object. We can just cast regions of the memory into typed arrays. Now, with these typed arrays, we can then do interesting things. So we can take the typed arrays and we can copy them straight into video memory, and then we can render them using the GPU, using the vertex and fragment shaders. Okay, cool. So that gives us a real performance benefit here. We can see that we can render 2 million points in under a millisecond, which is very fast. And then the full round trip time is about half a second on a 1 gig network, and on a 10 gig network it's about 200 milliseconds, but the data transfer size is about 500 megs, so most of it's data transfer. So the key takeaway is that we can render a ton of data really quickly. Okay, now on to streaming. Okay, so in dashboards, no external framework like PubNub or Lightstreamer is required. Streaming can be supported in Kdb itself via Kdb+tick. This implementation can be found in u.q, which, as you can see, is only a few elegant, albeit terse lines of code. But the main thing to understand is that these few lines provide a minimal publish and subscribe pattern powered by Kdb itself. So let's take a look at how it works. In any publish and subscribe pattern, you have publishers and subscribers. Publishers advertise a list of topics, here stored in u.t, such as quotes, orders, and sensors. And then subscribers express an interest in one or more topics by calling a subscribe function, u.sub. Additionally, subscribers can specify an optional filter, which is the second parameter here, to only receive messages that match that filter. So here we're the user subscribing for quotes with a filter of $euro and $sterling. The subscriber will then only receive quotes that match these currency pairs. On subscribe, subscribers are registered in a dictionary, u.w, and this dictionary maps the topics to a list of subscriptions, where a subscription consists of a subscriber socket handle like 624 or 600, and a filter, which is the currency pairs in our quotes example. Once a subscriber is registered, any external event, like a price change or a timer event, can push to a topic by calling the publish function. So we can call u.pub quotes followed by a table or a list of updates to be pushed. Finally, subscribers can be removed by just disconnecting, and Kdb+tick will clean up after itself, or calling u.delete to remove yourself from a subscription. So now that we understand how Kdb+tick works, let's build an example from scratch. So the first step is to download dashboards. To download dashboards, simply register on code.kx.com/dashboards. And here you can get a build of Dashboards Direct, which is free to use for up to 5 users. So we're going to use this to visualize our stream. Once we've downloaded, you can simply extract the folder. Here I've extracted mine to the desktop. Inside, then I'm going to start dashboards. So to do that, I click on dash.bat, then I get 2 processes, one a data process and one the actual dashboards gateway. Okay, next we want to look inside the sample folder where we're interested in stream.q. So I'm going to look at this in code. Okay, so this is where we're going to build a new stream on a separate process. So the first thing we're going to do is we're going to start our process. So here I'm going to start a process on port 6814. Okay, and then I'm going to define a table that I'd like to publish. For us, that's the waves table with a timestamp, a red, orange, yellow, green, blue, and purple value. And then we're going to load the tick library and we're going to initialize. Okay, and so now what Kdb+tick will have done is it will have taken all the tables in the root namespace, so that's just waves for us, and it would have initialized these into streaming tables. So now they're available in u.t, and u.w will have a dictionary which is currently empty, but with waves and no subscribers. So next we want to publish some data to our stream. And to do that, we're going to first have to generate some data. So I'm going to use a sine wave function here. First, I'm going to just execute my sine wave function, and then we'll jump to a little explainer slide. So here we can see that we're going to link time to the input angle, and then out of the sine function, we're going to get a wave as output. So using this, we can create waves from time, and we can also parameterize the shape of the waves with the parameters amplitude, frequency, and phase. Okay, so back to code. And so let's see what values we actually generate here. So this is my snippet. I'm generating 6 waves, and there's my incoming time that I'm using to generate them. So let's see. Yeah. So here, if we run it really quickly, we can get a general shape of the data and see the values that come out of it. But I'm going to publish these rows into the subscription topic waves. and I'm going to call publish from the timer function z.ts. Okay, and so then every specified interval, we're going to publish new records to our stream. And I also have to set up a snap function for dashboards. For the meantime, I'm just going to use the wave schema as a placeholder. And then lastly, we need to set a timer to trigger our timer function. So I'm going to go for 16 milliseconds, which is about 60 frames a second. Okay, so let's visualize this stream. Here we have dashboards running. So I'm going to drag out a chart.gl component. May as well make it full size. A data source. And I'm going to need to make a new connection. So here, go new. Set stream is what I'm going to call my connection. And it's on localhost. And the port I chose was 6814. Okay, let's save that. Looks good. Now, when I choose this connection, we should be able to browse and see the available streams in that connection. Which is brilliant. There's just one. Okay, so let's take a look at the stream. It seems to be running. Problem is we're keying here by row number, so it's just going to replace the value over and over again. It's probably better if I key by time. Let's try that. That looks much better. Okay, so let's choose this. And here we have some data flooding into our chart. And we can see the shape of the waves coming in now. I think I'll set the color of these waves while I'm here. So I think we have red, maybe a brighter red. Orange. And yellow. Green. Blue. And purple. Okay, so now we have my rainbow waves coming in strong. Now we can see that this is updating, streaming perfectly here at 60 frames a second. Our tooltips work. We can interact. We can zoom in. So I'll jump to preview mode. We can zoom in. We can see just how fast these are streaming in. Okay, here's the speed of them zooming in. We can zoom out and everything is interactive and snappy. However, we have one problem, and that is that when we load the dashboard each time, we can see that it has to catch up and fill up the graph bit by bit. So that's not ideal. This is because we're missing the snapshot functionality. Okay, so now I'm going to chop back to stream.q and we're going to add the ability to do a snapshot. So the first thing I'm going to do is I'm going to define a ring buffer. A ring buffer is a way for us to efficiently cache data, where we're going to have a fixed size buffer, and it's going to fill up to a certain point until it reaches the size of the buffer, and then it's going to loop round and write over itself again. But we can access the data like it's a fresh array, so to speak. Okay, so then I'm going to define my stream. I'm going to define the size of my buffer. I'm going for 20,000. Okay, and then I have a new stream generation function. And the only difference this time is that this is going to generate and save the new record to the buffer before returning it. So we'll then replace our timer function with this timer function, which calls the stream waves gen so that we can keep a buffer version of the last record. And most importantly, here's our snap function. So the snap function is going to read from our buffer stream.waves using the location stream.i of the last indexed item. So it'll take the most recent snapshot of our buffer. Okay, so that seems like everything is in place. We've got an efficient buffer, we've got a cache table, and we've got our generating function writing into our buffer, and our snap function is able to pull items out of the buffer. Okay, so let's see the difference now when we reload our page. And instantly we have a graph ready on the screen, no time to fill. And we can increase the size of this. So here, we'll now jump up to 20. It's going to fill up to 20,000 items. So when we reload the page, we can see the full breadth of the data continuing to fill up until the buffer eventually reaches its limit of 20,000. And then it'll just continue to scroll across. Okay, so that's streaming analytic created and rendered in dashboards. It's only about 5 or 6 lines to do a minimum version, and another 5 or 6 to do a buffered snapshot version. Okay, so once you're comfortable with this streaming sample, feel free to check out more samples in demo.q, which is also in the samples folder. And check out the corresponding demo dashboards. So this one looks familiar. We can look at test cat for advanced users only. But you're probably more interested in demo stream. So this is a financial sample where in the top left we have a ticking quote board with FX pairs. When we choose a different cell in the quote board, the corresponding chart is updated. Each of these charts are snapshot and subscribe subscriptions. So we're switching between different subscriptions on the selection. The same is true of equities here, where we can browse our equities. And with the equities, we also have fundamental data. Okay, so cool. That's about it from me. I guess I'd just like to thank you for watching. If you can, check out dashboards on code.kx.com/dashboards. We'll have another update out in October. And if you want to get in touch, reach out at the email addresses below. Okay.